Hello, ladies and gentlemen. This is a conductivity star. We've been looking at the idea of the conductivity of metals, and metals conduct electricity just great, but also they conduct heat quite well, but they don't conduct heat in the same fashion between different types of metals. Here, as we're going around the circle here, we've got copper, aluminum, brass. This is iron, or it might be steel, but steel just has a little bit of carbon mixed in with it, so it's essentially iron. And this right here is German silver, and it turns out German silver actually doesn't have any silver in it whatsoever. It is a combination of copper, nickel, and zinc. Now, also brass is a combination of zinc and copper also, but the whole point of this is that each of these have different thermal conductivities. So that means that if you have a central heating source, like this little burner over here, central heating source here, heat will move out through these metals, but since they're different types of metals, they have different conductivities. And so there's a certain amount of joules of energy per second that will flow out, or a certain number of watts of power will flow through these. And how can we go and see what this how these things respond to one another in a relative sense? Well, if you set this up kind of nice and evenly here, let's put this on. I'll take this away, conductivity star. And here, I've got some little pieces of clay, measured out each one of those pieces of clay as being 1 gram, rolled it up into a little ball, and I've got these little pennies. Now, I just simply take that little piece of clay and just push it down on the old penny here. Boop, boop. And what we're going to do is we're going to stick it to the ends of each of these different types of metals. So why don't I start right on over here with copper. I'll push it all the way on through like that, and try to do the exact same thing for all of these guys here. And if I do that, hopefully we'll get some good results here. Maybe this is not 100% perfect. Wanted to get the same amount of clay for each one of these weights sitting out there on the ends. Now let's see what happens here. Now what we're going to do, so that's all squished on in nicely. So how about I get this little guy around here, try and line that up. Might not look like it's lined up in the camera, but I'm looking at it from above. Getting that little guy lined up there. Let's get this thing going. There we go. Got a little bit of flame there. So let's see what happens as things heat. Which ones drop first? Pull that one out. Ah, it works better if you let air get into it. Okay, here we go. There we go. There's one. There's two. There's three. Oh, there's number four. And number five. There we go. Just took a few minutes for that to go. We have. Okay, now that's hot. Hot, 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 hot. So, can I turn you down? Even off, maybe. Alrighty. So, let's pull this out of the way. Whoosh, that's a bit toasty. Alrighty. So, what do we got over here? This is our conductivity star, and it's used to show the different thermal conductivities of different types of metals. All right, hey, thanks so much. And you'll notice, yeah, when we're looking at this, copper was first, aluminum, brass, iron, or steel, and this German silver, which has no silver in it whatsoever. It's just kind of funny that way. Hey, thank you so much, and you have a great day. Bye.